So now we move on to question number 2, where we are looking at calculating something called the relative formula mass of a substance. Now, the relative formula mass of any substance, it could be a molecule, it could be a compound, is the total, so the sum of the relative atomic masses of each atom that is part of that substance. Okay, so we're going to do this first of all for potassium cyanide. So that's KCN. So we've been given the formula of this substance and we need to find its relative formula mass. Now, often in the exam you will be given the relative atomic masses in the question, so we are given them here, but if not, then you can find them in the periodic table. So looking at this periodic table, you'll notice there are 2 numbers for each element. Okay, so if we consider boron just over here, okay, you'll notice there's a 5 and an 11. The 5 is the atomic number, tells us how many protons there are. The 11 is the number we're interested in. That is our relative atomic mass, okay? The total number of protons and neutrons, okay? So we're going to go back to the question. And as I said, we've got KCN, potassium cyanide, and we want to find out the relative formula mass. So what I would recommend you do in this situation to start with, if you're not feeling very confident, is to write out the formula and then write out the relative atomic masses of each of the different elements underneath. So we've got potassium, which is K, and we're told up here that K equals 39. We've got carbon, which is 12. And we've got nitrogen, which is 14. That's all of the atoms that are in here. So what we're going to do is we're going to add all of those numbers together. So 39 plus 12 plus 14, you put that into your calculator, you get an answer of 65. If you do that, that will net you 1 mark in the exam. Okay, so that's a nice simple example of calculating relative formula mass. So we move on to part 2. This time we're looking at a slightly more complicated one, so MgBr2, magnesium bromide. So once again, I'm going to use exactly the same strategy. I'm going to write out the formula of the substance, and I'm going to write the relative atomic masses of each of the atoms underneath. So we've got magnesium in there, which is 24, as we can see up there. And then we've got 2 bromine atoms present here. Now, the fact that we've got 2 means that we have to add 2 lots of the relative atomic mass of bromine. So you'll notice up here, it is equal to 80. So what I'm going to do is I'm going to write 80 there, and I'm going to split it again and say we've got 80 there because there's 2 of them, so I need 2 lots of 80. So if I add 24 to 80 to 80 and I do that calculation, I get an answer of 184. Okay, once again, that would get you 1 mark in an exam if you were to do that. Okay, so a slightly more tricky example now. This time we've got some brackets in our formula. So we look up here, this is calcium hydroxide, CaOH2, and we're given the relative atomic masses again. So like before, I am going to write the formula out like this. Now, just so you're aware, when we've got brackets in a formula, that means that we've got 2 or 3 or whatever the number is outside the bracket, we've got that many of what's in there. So this means that we've actually got Ca, and then we've got 2 lots of everything in the bracket. So we've got 2 lots of OH. So I've just written that over there. So when I'm calculating my relative formula mass, calcium is equal to 40. Then there's only 1 oxygen here, but there's a 2 outside the bracket, which means I've actually got 2 lots of oxygen that I need to consider. So I'll write my 2 16s. So we've got the 16 from up here, down there. And then the hydrogen, I'll write my 2 lots of 1 down here. Okay, because again, there's 2 of everything in the bracket. So now I'll add all of these numbers together. That will give me an answer, and the answer I get is 74. So if you got that, really well done, you get a mark for that. Now finally, we'll look at this example. This is probably the trickiest kind of example you could get. This is aluminium nitrate, so Al brackets NO3 close brackets 3. So what this is telling us, and once again I am going to write out my formula like I do every single time. This time we've got 3 lots of everything in the bracket. So we've got 3 lots of NO3. Okay, so if we count how many atoms we've got that I've drawn over there, we've got 1 aluminium, we've got 1, 2, 3 nitrogens, and then we've got 1, 2, 3, because of that 3 there, 4, 5, 6, 7, 8, 9 lots of oxygen. So we'll do what we did before. So aluminium's relative atomic mass is 27. We said we've got 3 nitrogens. Now, because I'm feeling a bit more confident, I'm going to write this out as 3 lots of the relative atomic mass of nitrogen. So 3 lots of 14. And then, as we said, we've got 9 lots of oxygen, because it's 3 times 3. And that is 16, okay, that we're timesing that 9 by. That's its relative atomic mass. So we're going to do 27 plus 3 lots of 14 plus 9 lots of 16, which gets us a rather large relative formula mass of 213. Once again, that would be worth 1 mark. If you can do that one, you can do any of them, because that is as difficult as it will get.